Okay, this is Math 2, Unit 10, Lesson 2, quadratics in vertex form. These, of all the quadratics, are my favorite form, vertex form, because it's easiest to graph and find information. All right, so this is the form we're using right here, vertex form. I am going to review standard form. This is the form we did last week. Does anybody remember what it was? Y equals something ax squared plus bx. No squared.
No.
Just bx.
Quadrangle.
Plus what? Plus what?
Plus 0.
C. Ax squared plus bx plus c. Are you guys short one?
Yeah. Oh, that's how. Yeah, I remember this.
All right. Hey, guys. Okay. This form, listening. This form is really nice when you're looking for the y-intercept. Because when you're looking for y-intercept, you make x equal to 0, 0, 0, and that last constant's always going to be your y-intercept. So if they're asking you for y-intercept, this is the form you want it to be in. There's actually going to be a test question like that, so we are going to go over it more, but I hope you're listening. If you're looking for the y-intercept, this is the best form, because you plug in 0 for x, 0 for x, and the only thing left is the constant at the end. All right, vertex form, it's right in the title. It's nice when you're looking for the what? It's right in the title. Vertex. That's why it's called vertex form. I sometimes call it descriptive form, so if I do know, I'm talking about this. Okay, here's what it looks like. Y equals A parentheses x minus h quantity squared and then plus k. That is vertex form. That is vertex form. It doesn't matter which, what was that?
That looks complicated.
It looks complicated, but we're going to like that one. Remember, A can never equal 0 for any of the forms. Your leading coefficient can never be 0. Please stop and pay attention. Okay, A and A, that's the only number they have in common. A is your leading coefficient. Are you guys writing this down?
Yeah.
Okay, this piece here is going to be quick review. This piece here is going to be quick review. All right. Yes.
I don't get the question it's asking right now.
There's no question anywhere. Right here?
What does it tell us about
Okay,
the graph?
thank you. I sent this to my last class. This I should have put in quotes. What does A tell us about our graph? What does the letter A is? And I didn't catch it until I was reading it to my last class. Was there a hand up?
Yeah, do you want us to answer that?
Okay, go ahead. Go for it.
It tells us whether the parabola is going to go up or down.
Good job. He said it tells us whether the parabola is opening up or down. When would it be opening up?
Down.
When it's positive. Okay, so if A is, leave space here, don't write really big because we're going to put more stuff. If A is positive, it's opening which direction? And if A is negative, what does that mean about the parabola? Which direction is it opening?
Down.
It's opening
Down.
down. Now we talked last week about maximums and minimums. What would this vertex here be called? A max or a min?
Max.
This one is the highest or lowest?
High.
Lowest, so it's called the min. Is this the highest or lowest on the graph? So it's called the max. All right, all of that is review. The next piece is also review, but now we're going to have it in our notes. We just did the other one during the worksheet. Absolute value of A. There's 3 possibilities. First off, why do I write it as absolute value? Because the only thing the negative tells me is that it's opening down. Other than that, I don't care about it. It's either going to equal 1, be greater than 1, or smaller than 1. Equal to 1, greater than 1 or smaller than 1. If it equals 1, we call that normal. Okay, so I'm going, you don't have to pull yours out yet, but this here, remember I called this one the parent function, y equals x squared, that's going to be what we call normal, our standard normal function. Okay, if it's bigger than 1, it's narrow. Good job. Kids often think, oh, bigger than 1, it means it's going to get wide. But does anybody remember what I said about when the number gets bigger, it does what at a faster rate? Starts with an I-N-C, it increases.
Inequality.
Right? So if I, guys, for example, 5 squared is what? 25. So if I went over 5 and up 25, but then I multiplied it by 2, I'm going over 5 and up 50. Do you see that I'm increasing at a faster rate? Yes? So the bigger the number, the more narrow it is. I'm going to put slash thin because sometimes I use the word thin, narrow or thin. Okay, so it's opposite of what you would think. If you're on your phone, it needs to be put away, please. And you need to be focusing with the rest of us. All right, so it's opposite of what you would think. You think, oh, bigger than 1, that means the graph is bigger. No, it's opposite. All right, smaller than 1, what happens? It's going to get wider. All right, so this, looking here, this is 1/2 smaller than 1? And was it wider than the original x squared graph? And 2x is bigger, was it more narrow? So here, yes, here's normal, narrow, wide. Do you see the difference? Now what happens the bigger the number gets? 3, 4, 5, 6, it gets more what? Gets thinner and thinner. And then what happens as this number gets smaller? 1/2, 1/3, 1/4, it gets what?
Wider.
Wider and wider. Okay, questions here. All right, I'm going to quickly list some numbers. What are some numbers that are big, positive numbers that are bigger than 1? 2, 3, 4, 5, ... 8, 100. And I see some of you guys back there not paying attention. Now what happens as we increase the graph gets thinner and thinner? Put it away. Or I'm taking it away if I see it out again. All right. Wide. What are some positive numbers? Because remember, absolute value means A has to be positive. What are positive numbers that are smaller than 1? And I think we talked about this last week. 1/2? 1/3? What about like 1/5 or 1/7? Would that work? What about 2/3? Is 2/3 smaller than 1? Yes. What about 7/3? Is that in the wrong spot? It is. Where should the 7/3 go? How can you tell that 2/3 is smaller than 1? 2 is smaller than? The top number is smaller than the bottom number. How can you tell that 7/3 is bigger than 1?
Because it's bigger than
The top is bigger than the bottom. All right. So what I'd like you to do now is take this back out. I told you not to put it away. Flip it over here. I want to talk about these now. Quickly, as quick can be. So everyone has this out. Okay. Positive, and I'm going to be calling on you, so make sure you are ready. Isaac, it's positive. X squared. Is that up or down? It's right here. Positive is opening which direction? Up. Ike, what is A right here that I don't see? 1. And the absolute value of 1 is bigger than 1 or smaller than 1 or equal to 1? Okay, so you tell me, is that wide, thin, or normal? If it's equal to 1, what is it going to be? Normal. Okay, so I'm just going to put up and normal. I'm going to graph it later. Next one, I will call on Wendy. It's negative here, -3. Is that opening up or down? I didn't hear you. Louder? Down? Okay, thank you. Jason, I take the absolute value of, what's that there? And is the absolute value, I'm going to put it down here, is the absolute value of -3 equal to 1, bigger than 1, or smaller than 1? What's the absolute value of -3? It ends up being +3. So +3 is Bigger than 1. Look at the notes we just took. If it's bigger than 1, is it wide, thin, or normal? Look at the notes.
Thin.
If it's bigger than 1, it is
Thin.
thin. If you put narrow, that's fine. I interchange between those quite
I like
often.
narrow better.
Okay, next one. I'm going to call on Dante. Is it opening up or down?
Down.
Down. Why?
Because it's less than 1.
Not, it has nothing to do with less than 1. It's because it is
Negative.
negative. Then we take the absolute value, I'm going to put it down here, of negative 1/4. Is that positive 1/4 or negative 1/4? The absolute value of negative 1/4 is positive or negative?
Positive.
And positive 1/4 is equal, bigger, or smaller than 1? Okay, so the smaller the number, look at your notes, what's going to happen? It's going to be wide. All right, last one. I'm going to call on Baloo. Opening up or down? Up. Can you tell us why? Positive. Good job. I take the absolute value of A. Do you guys agree A is always the first number, the leading coefficient? Yes. And I'm going to call on Andrew. What's the absolute value of positive 7/3? And is 7/3 bigger than 1, equal to 1, or less than 1? Bigger than 1. Do you guys all agree? It's a fraction, but it's bigger than 1. Yes or no? All right. So, Andrew, is that wide, thin, or normal if it's bigger than 1? Thin. All right. So now go through and graph if you haven't done already. Up and normal, this one is your parent function. And just make sure anything that's thin or wide is thinner than your normal or wider than your normal. So down and thin is thinner than this. This is down and wide. I'm going to erase that fraction there so it doesn't get in the way. Down and wide. And this one is up and thin. All right. Any questions on that? Does it make sense?
Yeah.
Okay. So again, this here was from worksheet 1, the one we did last week. Okay. Back here. Questions at all about all of this review here? This is all review from, except for this piece here. Any questions from that review from last week?
No.
Okay. Now we're going to take this. We're still going to use it, but we're going to apply it to vertex form. Are we ready? Okay. I'm going to have you write this down. Opposite of the inside. Write it down with me, please. Opposite of the inside. Opposite of the inside. Outside stays the same. Can you guys remember that? Opposite of the inside, outside stays the same. Okay. Now, I will tell you this. What I'm about to tell you right now, you are going to use like the whole first few months of Math 3. You get into Math 3, what I'm about to show you right now, you're going to be doing over and over and over with different types of graphs. Are we ready? Okay. Whatever's inside your parentheses, or it might be an absolute value, or it might be a square root, whatever's in the inside is always a right or left translation. It's always going to move right or left. And what did we say about the inside? It is what?
Opposite.
Opposite. Okay. So then the outside number, whatever's on the outside, is always going to be up or down translation. And that one's always going to be the same.
So what you're saying is, since what's in the parentheses is positive, it would be moving negative on the graph?
Yes. Not just negative, but which direction? Right or left? So she's saying this is going to move left 2, and then this is the same, and it's up or down. So up 3 or down 3. It's negative, so which way? Down 3. It's because when you set this equal to 0 is what you're technically supposed to do. And when it equals 0, you get negative 2. So you move left 2. All right.
still don't get it, but I'm not gonna question it.
For now, we'll do it, and then we'll get more practice as we go and discuss it more. All right, so does everybody see where I got this point by moving left 2 and down 3? Right or left, opposite, up or down, same. Does that make sense? Okay, now, it doesn't ask it here, but I need to do it in order to graph. I need to know it. What is the number here that I don't see?
1.
And is it positive or negative?
Positive.
So positive 1 means I'm opening in which direction? Up. So I'm going to write it here only because they didn't ask it here. And is 1, absolute value of 1 equal to 1, bigger than 1, or smaller than 1? All right, so would we call that wide, thin, or normal? Okay, they asked that. That's right here, so I'm going to circle it. All right, what is this vertex right here? That's my vertex. So how would I write this in ordered pair? Do you guys agree? If they didn't ask me to graph, guys, and that's why this is called vertex form. If they did not ask me to graph, if this middle piece was not here, and all they asked for is what is the vertex, should you know it's -2, -3 just by looking at this? Opposite of the inside, outside stays the same. Do you see why it's called vertex form? Okay.
Wait, why a vertex?
Because when you look at it, you can say, oh, the vertex is -2, -3 without any extra work. This form, you cannot do that. This form, we had to make the T-chart, plot all the points.
We did this in middle school, but it was called something else.
Okay. But does it make sense? No? Okay, well, let's we're going to do quite a few of these. So opposite, same, -2, -3. -2, -3. Left 2, down 3. It's opening up and normal. Here's what we're going to do for now. We're not going to make a T-chart, and we're not going to worry about intercepts. As long as you're opening it up and normal, whatever your normal is, make sure everything else is wider or thinner if it needs to be. And I'm going to draw in my axis of symmetry. We did talk about that last week as well. It's right there. Will your axis of symmetry always go through your vertex? Yes. Yeah. Yes, it will. All right, what's the domain for all parabolas in this class?
All real numbers.
All reals. Next year you learn different types and restrictions. It'll be different.
Okay, but if it's always gonna be that, why is the blank there?
To write it in? You need to know it. Just because it's always the same doesn't mean you don't have to know it. So it's all reals. Guys, in Math 3 you have restrictions. It's no longer all reals. And you have parabolas that open sideways.
How does that even?
So that's a whole other stuff. All right.
So weird.
Axis of symmetry. That's this line right here. What axis does this line intersect? The x-axis or the y? At what x value? So I write the axis of symmetry like this. X equals -2. Okay. Here's what they're going to say. What's the equation of the axis of symmetry? And kids are like, what, the equation? That's just trying to remind you to write not -2, but x equals -2. Okay, you have to remember it's an equation. X equals -2.
It's just a really tiny
It is a tiny one. All right,
equationette.
guys. Maximum value of the function. I'm sorry, minimum value. Is this a maximum or a minimum? Any thoughts on what the minimum value is? -3 is correct. It will always be the y value.
What's the range?
Oh, thank you. I will go back and put it in there. Okay, really quick, guys. When they ask for the maximum value or the minimum value, it's always going to be the y value of your ordered pair, of your vertex. If they worded where does the minimum occur, then they're asking for the x value. For now, you just need to know when it asks what is the minimum value, that's the y value.
Are we gonna see where does the minimum occur on the test?
No,
Oh.
but you will next year. And you might on a worksheet here and there. Yes,
The range is y is greater than or equal to -3, right?
good job. Does everybody agree with him? Greater than or equal to -3? Why is it greater than or equal to? Because it's opening
Down, up.
up. And -3 because that's where it starts to open up from. Do you guys agree?
How do you graph it?
I just went left 2, down 3, and I knew it was up, and I knew it was normal. That was it. Yes.
On number 2, -2,
Mm-hmm.
does the -2 that's outside of the parentheses determine how like wide or narrow it is?
Yes, not the negative piece, just the 2. Okay, so this has a lot to it, guys. Is that if that's your normal? Yes.
I don't know.
Okay, listening, please. Evan, which way is this telling me right here to translate? Right to or left to if we know it's opposite of the inside?
Right.
Right to, good job. And then I'm going to call on Ronnie. Is this up 1 or down 1 if it is the same?
Come on, Christian.
Down 1. Right 2, down 1. Okay, so what is this vertex right here? What do I put here as the vertex? Positive 2, comma. Could you do that without using the graph? Opposite same, positive 2, negative 1. Yes or no?
Yeah.
Okay, now this negative here is telling me it's opening up or down? Down. Now you take the absolute value of that -2. I'm going to circle it and put an arrow there. The absolute value of -2 is what? And is that bigger than 1, equal to 1, or smaller than 1?
Equal.
Positive 2 is
Wait, nah.
bigger than 1. Look up here. What does it mean if it's bigger than 1? Narrow. So I'm going to circle the narrow.
What
So,
is the range though? Like, I don't know how you do that.
okay, I'll do it with you guys on this one. Okay, so I'm going to open it up, and it has to be more narrow than your normal graph.
I bet it's supposed to go down though.
And it is. Thank you very much.
Ah,
Ah,
I already marked it.
white out it if you're using pen.
Yeah, can you tell us what
Yeah, can you hand this to her, please? All right, Isaac, thank you for paying attention enough to catch that. All right, hey.
How rude.
Okay. Axis of symmetry, I want you dotting. We're all listening. Okay, domain, we should know at this time is what? Does it matter if it's opening up or down? No, because it's getting wider forever. Okay, range. Hal, that this is the part you were asking about.
Yeah.
On your range. Is that my orange pen?
Yeah, maybe.
Okay. Make sure.
Sorry.
It's okay.
Yeah.
All right.
Sorry.
Range. Listening. Is the range is a set of all y values. Is the graph going up and down forever?
I can't see, man.
Is it going up and down or just down?
Just down.
Just down. So would that be greater than equal to or less than equal to? What y value? -1. Okay. Shh. Guys. Axis of symmetry. Do not forget it's an equation. X equals what x value? Right here. X equals 2. Okay. Maximum. That is a maximum. What's the maximum value of this function?
Negative.
Is it always the y value when they ask for maximum value?
Yes.
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 If they're asking for the x value, it would say, where does the maximum value occur? It occurs at 2. Okay.
Mr. Boyer, I still don't understand the range.
Okay. It's
It seems like every time you try to explain how you get it, I just miss it.
okay.
entirely.
I called you this time. If it's up, it's greater than equal to. If it's down, it's less than equal to. Do you see the greater than equal to?
Oh,
Less than equal to, and it's always from the y value at which it goes up or down from.
so the number you put at the end of it is just the y value.
Yes.
That's a lot simpler than I thought.
Why is it -2, 3 on the first one?
Okay, repeat your question.
It's the vertex is -2, 3. Why?
No, it's -2, -3.
Okay, negative. Why is the 2 negative?
Because it's opposite of the inside, always. That's why this -2 became +2, because you take the opposite, same.
Oh.
It confused me too, don't worry about it.
Oh.
Can I get some water?
Hurry, please. All right, we're going to get some more practice. All right, flip it over. It's the way all translations work for all functions. Shh. Stop the talking, please.
Back?
Yes, backside. You were supposed to have a backside.
I check the notes again.
Can you just staple it since you've already written all over the front side? All right, backside. Guys,
Who is it?
shh. They didn't ask for the vertex, but can anybody tell me what it is just by looking? -3, +5. Do you guys agree with that?
Yes.
Let's see if we get that when we graph. This is right or left. Which direction am I moving? Right or left 3? Opposite, so right or left 3. And then same, up or down 5. 1, 2, 3, 4, 5. Do I end up with -3, 5 as the vertex? Yes? All right, gentlemen, please stop. Okay, it didn't ask it here, so I'm going to write it over here. Is it opening up or down? Down. And the absolute value of -1/2 is 1/2. And what's the comparison between 1/2 and 1? Bigger, smaller, or the same? And it's opposite of what you think. The smaller the number, what happens to the graph?
The wider it gets.
It gets wider. All right, so I don't have any intercepts right now. Stop the talking. I do not have any intercepts right now, and I'm not going to care about them until a few more days. We just need to know it's opening down and wide.
Oh wait, so next lesson we're gonna learn how to calculate
Intercepts.
numbers in this. Oh.
Yes. All right, so here is my axis of symmetry. I didn't ask for it, but I'm still graphing it. And I'm actually going to write down what the equation is. X equals what? What x value does it cross? -3. Okay, does the graph have a max or a min? Max.
Or man.
Max, because it's the highest point. Okay, this next piece right here, I'm going to tell you right now, this is where kids struggle on the test. So if you've been half listening or not listening, I need all focus up front now. Okay, here's the easiest thing to do. First, ignore the graph. Do you guys agree from elementary school on a number line, when you first learned not 0, 1, 2, 3, 4, 5, and on, right? If you were to cut it vertically like this side would be bigger or smaller, the numbers to the right? Bigger. And the numbers to the left? Smaller. Smaller. Now, when you went on and learned negatives, 0, and then 1, 2, 3, 4, and -1, -2, 3, and -4, it didn't matter where you cut it. If I cut it here, are the numbers to the right still greater than? Yes. And the numbers to the left still less than? Yes. Okay, that's what we need to know. So, we're always going to cut at wherever our axis of symmetry is at. I'm going to erase this vertex marking for now. And what did we say the left side's always going to be? Less than, and the right side's always going to be, it doesn't matter what graph you have. On any number line in the world, right side is always going to get bigger, left side's always going to get smaller. Yes or no? Okay. Now, here's what you do. When you read your graph, read it like you would a book, from left to right, always. So from left to right, think of this as a hill. If I'm starting here and going this direction, am I going uphill or downhill? Uphill. So would that be increasing or decreasing? Decreasing. Increasing, right? Uphill is increasing. And then I get to the vertex, and what happens at the vertex as I continue to walk? I start to what? Decrease. I start to go downhill, which is? Decreasing. Does everyone see that the left side is increase and the right side is decrease? Yes or no? Yes? Increase, decrease. All right, so when it asks for this, you will always use X. You never use Y for increase or decrease. You only use Y for the range, and that's it. Okay, as long as you have this labeled, you're good. Increasing is the left half, so that's less than. Decreasing, good job. Decreasing is the right half, that's greater than. And it's from this line right here because that's where it changes. What's that X value?
Negative.
So X is less than -3, X is greater than -3. Please listen. Gentlemen in the back. It's not always going to be this way. Increase is not always less than and decrease is not always greater than. You have to look at each individual graph. Let's try the next one. Which direction am I moving? Right 4 or left 4?
Right 4.
Right 4, 1, 2, 3, 4, and then which direction?
Down.
1, 2, 3. Am I opening up or down if it's positive? Up. The absolute value of 2 is 2. Is 2 bigger than 1 or smaller than 1 or equal to? 2 is
Smaller. Bad. Greater.
Greater, and the bigger the number, you think it'd get bigger, it does what?
It goes,
The bigger the number, thinner or wider?
wider. Thinner.
Thinner. All right, so I'm going to draw in my axis of symmetry because I know it always goes to the vertex, and I know it's opening up and thin. Again, I don't worry about the intercepts right now, just up and thin. Okay, does the graph have a max or a min?
Min.
A min. I'm going to put x into x. I'm not even going to look at the graph. I'm going to extend this dotted line up. What do I know about the left half? The left half is always less than, and the right side's always
Greater than.
It doesn't matter what the graph looks like. Do you agree numbers on the left are always smaller than numbers on the right?
Yeah.
Okay, now let's walk on our hill. From the left side, am I going uphill or downhill?
Down.
So this would be decrease, and then I hit the vertex, and when I continue to walk, what happens?
You
Uphill, so that is increase. Okay, increasing is the right half, that's greater than. Shh. Decreasing is the left side, that's less than. Did these signs flip around?
Yes.
Yes, so you can't remember them, you have to look at the graph. Please stop and listen. What is this x value at which it changes decreasing to x to increasing? 4. X is greater than 4, x is less than 4, not negative 4. And no equal bar. Any questions? Okay. Next piece. I want you to write down the a value for every single one. What's the a value for the first one? What's the a value for the next one?
4.
Okay, keep writing them down. Don't say them out loud, just write them down.
What do I do? Oh, wait. Yeah.
What is it for number 5?
Would it be 1?
1. Positive 1. 2, negative 4, 6, negative 1/4, and 1. Do you guys all have that? Okay. Moving on. Moving on. It's positive 2, negative 4, 6, negative, positive. Okay. If it's positive, which direction is it opening? Negative is opening down. Keep filling it in. Do not say it out loud. All right. It was not intentional for it to have that pattern, but it ended up being up, down, up, down, up. Yes or no?
Yeah.
Okay.
Oh my God.
Wide, thin, or normal. Remember, you take the absolute value of the leading coefficient. When you're looking for wide, thin, and normal, you take the absolute value. Okay, what's the absolute value of positive 2?
2.
And 2 is bigger than 1. Opposite of what you would think. That's going to be wide, narrow, or normal.
Wide.
Narrow,
Narrow.
right? The bigger the number, the thinner the graph. Okay, next one. What's the absolute value of negative 4?
Narrow.
4?
4.
And 4 is bigger than 1. Is that also narrow?
Narrow.
And next one, absolute value of 6 is 6. Is that also narrow?
Yes.
And 1/4. What's the absolute value of 1/4?
1/4.
And that is equal to 1 or smaller? So that is what? Wide. And the last one, 1 is equal to 1. We call that what? Normal. Okay. Quickly write down the vertex. We'll do these last two tomorrow, or I will see you guys tomorrow.
What's the vertex?
The vertex. What did we say was the vertex? Opposite of the?
That.
Opposite of the inside. Outside stays the same. So what is it going to be here? Positive 5, positive 3. What about this one? Positive 2, positive 8. This one?
5 and negative 7.
5, negative 7. Remember, opposite, same. This one's a little tricky. Negative 3, comma, what's out here? Don't say 1. 0. Negative 1, comma.
0.
No, you're right. Negative 1, 0. And then the last one is negative 1, what?
1.
Nope, negative
0.
1,
2.
negative 2.
4.
Opposite of the inside, outside stays the same. Does that make sense? Yes? All right, we'll do these two together in class tomorrow.
Do we take this home?
You take this home. Guys,